continuing a similar theme. I'm just going to give a quick overview of one of the projects that I've been involved in. I'm looking at very, very low-cost wind resource monitoring, so a little bit different from energy, but yeah, I've been working on this with a little bit on my own, and a little bit with some input from John. Then asked for a few systems, and that spurred me to do more. Been working with Tom, and so Tom's going to present next. So one of the issues that I'd seen, certainly when working on small wind turbines in the Philippines, was that you see these maps of wind data, and they're over a kilometre square or something. They're generally done by satellite data of the. Someone got another one, basically. They're generally done over kilometres square, so they're taken from satellite data above, maybe correlated with local wind speed data, and that would be best. But when you actually get to the site, it's very variable, as shown by Marco. There's lots of different variations for a very specific site. So the wind speed measurements are very variable. If you're installing a large wind farm, then you can spend a few $1,000s on a decent logging system. If you're installing a wind turbine that costs a couple of $1,000s or less, you can't spend that much money. So I was looking at a very low-cost data logger unit to take readings of wind speed and wind direction in remote locations. It was part of I've been asked to do a little bit of other work, so I see it as part of a bigger project, which is to monitor lots of different resources. So we could look at solar. I've designed some sensors which monitor flushing of latrines in remote locations. So they sense when someone has put some water down the toilet, and they log that for a group called Water for People in Uganda. And we're getting that prototype sorted out, but it uses the same hardware. So I wanted to make it very low cost, simple to use. It had to be standalone. It had to just sit there and do its thing without any electricity supply, any internet connection, nothing like that. I wanted it to be open so people could upload their own software. I think that's true with everyone here. We're all things. I'd like people to be able to make it themselves, and I'd like people to know about how to maintain and fix it. So I looked around at different types of anemometers. Anemometers are devices with wind speed. Cup anemometer, and there is an ultrasonic anemometer there. I've worked with a number of different anemometers, including NRG ones and vector instruments. We stopped doing that. And eventually I looked around. These cost quite a lot of money, a few $100s. I looked around and I found this one from Maplin Electronics in the UK, and it was about $3. So it's like, well, that's very cheap. Obviously, it might not be very good, so I'm not saying this is the best in the world, because it virtually definitely isn't. We have one here. And that is the wind vane that goes to the sun. They've been designed for going with very cheap weather stations, so they're a replacement part for a very cheap weather station. So anyway, I got some of these. I mixed that with a board that I developed for another project to monitor temperature and water flow, which I called the Data Duino because Duino on everything. This is a circuit board which has an Arduino compatible IC in it. It's the same as the Arduino Uno, and it has a few other things in there. I also developed a small add-on, what's called a shield. There's one there. When we started to do this project, so this was originally designed for another project, and then I bumped on the wind logger shield. This, very simple, takes in some pulse inputs, and it records everything to an SD card. So the main features of it, it's an open source design done in KiCad, which is an open source electronics design package, PCB package. It's written in Arduino code, Arduino program, which I'm trying to turn into a library at the moment. I'm an electronics person rather than a software person. We need to know, we want to record data, we want to record the wind speed and the wind direction, and we want to know at what time that occurred. So we have a thing called a real-time clock, and that's a little chip that goes on here. And I also wanted to record that data onto something that's cheap and really easy to get hold of. So I decided to use an SD card. The data is stored in a .csv file, and it's designed to be human readable. And on Thursday we'll be doing a demo of this, and we'll have a look at some of the data in smaller groups. So I'll explain that a bit more. So I made a couple of prototypes. One of them, and it has prototypes. They've been installed in a number of locations, including my garden, and John's taken some to Argentina, and they've been installed in, well, various places in South America. It really needs long-term testing, which is kind of one of the reasons why I'm here. I like to talk to people who are interested in this kind of thing, and people who are doing similar stuff. And it really needs much more long-term testing. Other things I've been working on is remote power, is with solar input. Yeah, here we go. So some of these have been built as a DIY workshop where people were soldering everything together. And I still, from the ones that have been installed, I'm awaiting feedback and data. Tom Dixon has used the same baseboards, and he's going to talk about his experiences with it. So there's lots of work to do, as with all of these projects. I saw this very much as measuring resource. So wind speed and direction. It could be used to do quite basic power and energy measurements. So additional sensors which plug in, and they can do different things. We can look at solar, we can look at temperature, we can look at water flow for hydro and things. I need to redesign the PCB. I'm looking at incorporating the solar charging with a lithium battery so that it's a little bit smaller and easier to just plonk in any location. Also things like adding on displays if you would like them. They add to the cost, obviously, so that's one of the issues. And also sending the data either by Wi-Fi or by GPRS, text message, or things like that. I'm also quite interested in trying to make anemometers. If they're $3, maybe it's not worth it. This is a 3D printed anemometer. Took 2 hours to print, and it's, you know, it's not perfect, but it's interesting, and maybe I'll work more on that. So I'm interested to being here for people to get involved, chat about designs. All of the information is on my website, which is in www.reinnovation.co.uk. So yeah, just get involved. There's also another little bit of a plug that's free. If anyone would like to download a book that John and I and some others have been writing, there's a book on energy in a development context. It's free to download. It has been done with Engineers Without Borders, and you can download it by going to the website there and downloading the PDF on that link there. So that's just a little bit of a plug aside. Okay. Thank you very much.